This is your textbook, your main textbook, the one by Revell. And I'm starting today with the measurements here. Most of the information that we use in our class will be coming from measurements. Today in the lab, I showed you how to use scientific notation, and I showed you how to convert numbers to scientific notation from ordinary notation, and from ordinary notation back to scientific notation. I want to put some practice problems on the canvas for you this week about that. I also want to show you where to find more practice problems if you want. Many of you, probably most of you, should do more problems than what I assign for homework, and this is where you could find those more problems. If you go to the canvas, there is a tab called Files on the left. If you click on Files, you will be able to search for the document called tro4th.pdf, tro4th.pdf. If you search for that document, you can just click on it and download it. That document is an old textbook that we used to use here at ELAC. I put it in the canvas because it is an old textbook. There's no one who's going to be selling this. And also because it still contains valuable practice problems for you. Let me show you what I mean. If you download that and search for scientific notation, you will eventually find these examples. These examples are all worked out for you, and they direct you to other problems in this same document which offer you more practice. So this is where you're going to find your extra practice. You can find the same explanation that you see in our textbook in this textbook of scientific notation. Of course, there is a third textbook which I have a link for you to on our syllabus. The third textbook is the free textbook called Chemistry. If you view it online and you search for scientific notation, you'll find that Appendix B, so this page is in what is called Appendix B in this free textbook. They've got a few more examples for you to see here and for you to work out on your own. They do not have practice problems about scientific notation in this textbook, but they have practice problems about other things in this textbook that will make this textbook useful to you when you study for your quizzes and your exams. Now, back to our textbook and the measurements. We went into the significant figures when you multiply, divide, when you add and subtract. And we did not go into how to do scientific notation when you're multiplying or dividing. Now, when you're multiplying or dividing, you could handle the scientific notation by hand, as shown on this textbook page, but I do not recommend it. I recommend that you use your calculator to multiply and divide scientific notation, because there is a special button on your calculator specifically designed for this purpose, and it will help you to avoid errors. But when you are adding and subtracting, I do not recommend that you just use your calculator. You're going to need your calculator, but you're also going to need your hand and a pencil and a piece of paper. Here's what I mean. Suppose you want to add these numbers using scientific notation and giving respect to the rules of significant figures. If you want to add these numbers and you do it on your calculator, you're going to get some answer that is hard to understand. Let me show you that answer. 6.023 scientific notation 3 plus 2.81 scientific notation 2 negative. See this answer here? 6,023? I have no idea what's significant here and what's not. So to make this easy for me to see, this is what I do. I write the number out in normal notation. And I line up the dots, just as you used to do in elementary school. right? See, now I have a clear idea of where I need to stop the significant figures. This is addition, and the rule is that in addition and subtraction, your answer can only be out to the significant figure's place that the roughest measurement is. So here is the roughest measurement. It goes to the ones place instead of the, what is this, the 10,000ths place. So that means your answer can only go to the ones place. So this number goes to the ones place. Your answer can only go to the ones place. So although the calculator said 6,023.0281, the correct answer is just 6,023. It's easiest to see that kind of significant figures rounding when you write out the number in ordinary notation and not scientific notation. Sometimes it's hard because if the scientific notation is very large, then what are you going to do? You're going to sit here and write 19 zeros for your 6023, or was that 19 zeros or 20 zeros? You're going to write 20 zeros there? No, you're not going to write 20 zeros. So in this type of case, it's a little harder, but it can still be done. Here, let me show you exactly how to do this type of problem. So if you have this large number and this smaller number, how do you know where to stop? How do you know where to round things off? Well, this number right here, this is in the place of 10 to the 23rd. So here's what I mean by that. If you say 1984, right? This number 4, that's the ones place. This is the tens place. This is the hundreds place. This is the thousands place. You know that, right? I'm telling you, this can be thought of as the 10 to the 0 place, 10 to the first power place. This is the 10 to the second power place. This is 10 to the third power place. The reason why that's useful is because it's hard to know what is the name of the 10 to the 23rd power place. Is that the 100 trillion, 100 billion? Is this the 10 quadrillion? What is that? It would take some time to figure that out, so we just use numbers. This is the 10 to the 23rd power place. This here, this is the 10 to the 22nd power place. This here, this is the 10 to the 21st power place. And this here, this is the 10 to the 20th power place. You see that? What about this? This is the 10 to the 3rd power place. This is 10 to the 2nd power place. And this is the tens place, 10 to the 1 power. So just from these little notes that I've made about these two numbers being added together, I could already see that this number here doesn't matter at all. It goes to the ones place, but this number goes to the 10 to the 20th place. The 10 to the 20th place. That means the answer here has to end with some number in the 10 to the 20th place. So that means the answer is still just 6.023 times 10 to the 23rd. There is nothing in the 10 to the 20th place or even the 10 to the 19th place in this number, so this number doesn't matter for this addition problem in chemistry. So that's how you would figure out how to add or subtract something in scientific notation. That's how you should do it, with pencil and paper. You will not have to do this very often. Maybe just once or twice in the whole course. Now I want to tell you about some units of measurement. I showed you some things with the units of measurement in class today, and I'm going to tell you some more things, but I think I'll do that in a separate video.